Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 33, which is a new item type called drag and drop, off the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we've got a drag and drop here, so you see we're just going to drag some answer choices into just these two options right here, and you can't use the same one twice, and if you just try to use one answer, it is going to pop up with an error saying you have not answered everything. Alright, so let's look at two dilations, and that term dilations, that's going to be very, very important. So let's pretend we don't know what this term means, okay? So let's just see what we could do kind of without that, and then we will kind of take a look at how that term dilations really gives us a really quick way to solve this problem. So let's look at this first one, this triangle, okay? Dilated by a scale factor of 1/2, okay? So if we were to draw just a coordinate grid right there. We've got the center of the dilation at the origin. Okay, so I'm going to just draw a triangle like this and try to put the origin at the center. That looks close enough. Okay, so what's going to happen when I've got a scale factor? Well, if I'm not really sure what dilation means, I could hopefully clue in on this word scale factor. Okay, so a factor, since we've been learning about this in the 3rd grade, factor is a number you multiply by. So when you think of factor, you should be thinking, okay, multiplication. And that is correct. So we're going to multiply something, but we're going to multiply it by 1/2. All right, so what happens when we multiply by 1/2? Well, when we multiply anything by 1/2, right, like 4 times 1/2, that's just going to equal 2. 10 times 1/2, that's going to equal 5. So when we multiply by 1/2, it tends to shrink. So it might be kind of something like this. Right, it shrinks by 1/2. All right, so what would be the best way to represent? I see this half right here, and I see this half right here. So it's going to be one of those two options. But as we can see, the second choice right here, we're multiplying x by 1/2. We're multiplying y by 1/2. That makes sense. We're just minusing 1/2, so that's not going to really do anything. That's actually just going to shift it to the left a little bit and down a little bit. So it's not going to be that one. So on this one, we are going to multiply, because it is a scale factor, by 1/2. All right, so let's go to this next one. Square is dilated by a scale factor of 2, so I'm going to draw another coordinate grid here. I'm going to draw a square. It does say that it has the center as the origin, so let's just make a square right here. And then once again, it's a factor of 2. Okay, so what happens when we multiply by 2? Well, it doubles, right? It's going to grow. So that's going to be 20. All right, so I'm thinking then it's going to grow twice as big. It's going to be huge. It's going to be off our grid here. So then which one of these is going to best represent, doubling? Well, it's not going to be plus 2. That's just going to shift this up 2 and over 2 to the right. It's just sliding it. These two are slides. Now what we need is this one is going to multiply by 2. And that's kind of the trick. If you know what a dilation is, a dilation has a very simple formula, right? You have xy, and then it goes to kx and then ky. There's a scale factor that you multiply by, and so once you recognize that, you're like, oh, I need to multiply the x and the y by that scale factor, either the 1/2 or the 2. And those are our answers.